This is the levitating balloon experiment by Group 3B. The purpose of this experiment is to find the charges of two balloons using Coulomb's law. The overall findings were that the charge of both balloons was 3.699 times 10 to the negative 6 coulombs. Some background information is that Coulomb's law states that the electrical force between two charges is directly proportional to the charge on the object and inversely proportional to the distance between the two charged objects squared. It is also important to understand that this law can only be used with point charges. The electrical force is the attractive or repulsive interactions between two charged objects. Another thing to keep in mind is that like charges repel and different charges attract. So some models that were used during this experiment include Coulomb's law, which was just defined, and there's a picture that shows the equation and the components of it, such as Coulomb's constant, the charges, and the distance. Another model that was used is the system schema, which shows what is in the system, which is the balloon, string, and earth, and forces on those things. The forces are also shown in the force diagram right below the system schema. This shows that there are three forces acting on the balloons. There was a gravitational force, electrical force, and other charge of the other charged balloon, and the tension force of the strings. The other two models shown here are the drawings used to understand what forces were on the balloons and which variables that needed to be solved for. Then there is also the energy bar charts, which shows the transformation of energy throughout the interaction. Before the balloons moved, there was all electric potential energy, and then as the balloon started to move, the kinetic energy increased greatly, while the potential energy decreased. Then the kinetic energy decreased, and the potential energy increased in the negative direction as the balloons moved farther apart. Eventually, the balloon stopped moving, so the kinetic energy was zero, and the potential energy was all negative. These charts also show that energy was conserved.
For this experiment, two identical charged balloons were suspended and were seen to repel each other. The distance between the two balloons at maximum repulsion, the length of the string, and the mass of the balloons were recorded and then used to calculate the tension, gravitational, and electrical forces. It was assumed that the tension force in the x direction is equal to the electrical force, and the tension force in the y direction is equal to the gravitational force. The overall net force is zero, and that the two balloons had the same charge because they were rubbed on the carpet the same number of times. It was found that the average charge of the balloons was 3.699 times 10 to the negative 6 coulombs. In order to calculate this, the angle between the two balloons was found and used to calculate the tension force both in the x and y direction. Because the overall net force was zero, the forces in the x and y direction were set equal to zero. Once the tension force was calculated, the tension force in the x direction was used to calculate the electrical force. Then the electrical force was set equal to Coulomb's law, where the charges were calculated. Q squared was used because the charges were equal. To find the number of electrons transferred, the average charge was divided by the charge of a single electron.
Parts of the model were shown to be accurate because it showed a proportional relationship between the charge and electrical force, but it was also shown to be inaccurate because it was seen that the electrical force and squared distance was found to be proportional and not inversely related like they should be. This inverse relationship or proportional relationship can be seen in Figure 10. Multiple trials were done and other outside variables were controlled in order to ensure accuracy in the results. In conclusion, for this experiment, the average charge of the balloons was found to be 3.699 times 10 to the negative 6 coulombs. This value was found using Coulomb's law and finding the forces that were acting on the balloons. 2.309 times 10 to the negative 25th electrons were found to be transferred from the carpet to the balloons when they were charged. The balloons also repelled each other in each trial that was conducted, which lines up with what is expected because both of the charges are positive and the same value.